today we are going to cover. What are we going to cover today, folks? Can anyone comment the topic down in the chat box? If you know, I can give a hint. Pipeline. Yeah, I can see CI/CD pipeline. Yes, you are correct. Nimesh, please change the slide to the meme one. Can you guess the meme? Anyone from the audience? Type it in the chat box. Oh God, you got it already. Yes, that's the meme. CID and the CICD with an extra C. बचपन में तो CID सबने देखा है, right? It was my favorite show. Such a thrill we had watching it, and I promise you that the same thrill you will have when you watch automation on the CI/CD pipeline. So jokes apart, don't worry if you are just a beginner because our speaker Kunal Verma is here to make things easy for you. So, without any further ado, I would like to welcome Kunal to the stage. The stage is over to you, Kunal.
Okay, thanks for the intro, Kiran. Very, very happy to be here. And I hope I'm audible, firstly. Let me confirm that.
Yeah, you're audible.
Cool, cool. Okay, I see a lot of things going on in the chat, and I like the way you play with memes. I've been following the announcements channel for a while now. So great, and thank you so much for inviting me today. And yeah, I mean, today we'll be talking about DevOps practices and what exactly is DevOps, right? And how CI/CD pipeline come into the picture. We'll definitely be going through a practical hands-on demo of how does a CI/CD pipeline looks in real life. So I definitely agree that CID in our childhood used to give us a lot of excitement, and running a CI/CD pipeline will definitely give us a lot of excitement when that happens. So let me just share my screen and I'll get started. Uh, I just hope my okay. Yeah, I think I'll go with this. Just let me know if my screen is visible to everyone. Just a thumbs up or
Yes, yes.
cool. So yeah, just let me check it once. Yeah, cool. So okay, so hey everyone again, welcome to this particular workshop. Pretty excited for this one, and this is week number 3. As Kiran mentioned, you all have been learning some interesting stuff in week 1 and 2. I believe you learned about Linux, and you also learned about the networking concepts by Siddhant. Yeah, pretty interesting stuff. And today we are going to take this up a notch, and we are going to learn about what exactly is DevOps, right? And how does the CI/CD, what is the CI/CD pipeline basically, right? You might have heard from people talking about, hey, I broke my CI/CD pipeline. Hey, there are these like hundreds of builds going on, and I was able to successfully automate my project. So that automation thing that you all might be hearing from the community, that is what we are going to see in this particular workshop, right? Cool. Again, a little bit about me. My name is Kunal, and I am working as a DevRel at Cube Simplify, where we are simplifying the cloud native and WebAssembly ecosystem for everyone. If you have been involved in the community, you might have heard of Cube Simplify, because we have been doing amazing stuff in the community. So you can check us out. I'm also an open source advocate. That means I really love helping people out in getting started with open source, DevOps, and cloud native in general, because when I got started, the community actually helped me to get started and to set me on the right path. So I think that's my kind of duty now to help others get started, help especially the beginners who are struggling to contribute to open source or contribute or get involved in DevOps and cloud native ecosystem. So I think uh, because it's just amazing to get involved, right? Cool. So okay, this is the agenda for today, right? Don't get overwhelmed with the topics that we are going to cover because I'll be going through a very slow paced kind of a thing, and I'll go very slowly and cover each topic. So we'll be first covering about traditional software development, then what is DevOps, key principles, what are the different stages of DevOps, what are the DevOps practices that make up the entire DevOps pipeline or the DevOps lifecycle, and then we'll cover the CI/CD aspect of DevOps practices, right? And at the end, to uh, cherry on the top, we'll also be looking at a demo, right, where I'll be showing you what does a CI/CD pipeline look in real life and how does that automation looks in real life. I think I'm pretty excited. Let's get started. Okay, a few things before I jump onto the main topics. The main crux of today. This is a very beginner oriented session, right? So if you have prior knowledge of DevOps already, if you have prior knowledge of what is a CI/CD pipeline, you can just write it in the chat, and it will be glad for me to know. But if you're a beginner, if you are just starting your journey in DevOps, if you don't know what is DevOps exactly, if you don't know what a CI/CD pipeline is and how does that automation looks in real life, this session is for you, right? This is a very beginner oriented session. I've tried to keep things very very simple for you all. I'll go in a very I'll basically go in a very slow pace and explain each and concepts very clearly, so that you can start learning about DevOps, and you can start learning about different advanced concepts. So this session is basically you'll build a solid foundation for things to learn in the future. I'll be sort of going over the slides plus a few diagrams that I have prepared. I'll be also hand drawing a few stuff in between. So to in order to make things clear for you. Again, this is the method that I love to teach, and I think that will help you to learn as well. Just a second. Yeah. Okay. Now this is important, right? So language. I want you to decide, the audience who are here with me today. I want you to decide whether you want the session to be in English or should I use English. So in between Hindi and English as well. Just let me know in the chat anything that you're comfortable with. I'm comfortable with both, but in the end, you should be able to understand the concepts clearly. Let's see what the majority of the people say here. इंग्लिश की क्वेश्चंस पंचलाइंस का मजा हिंदी में आता है सही बात है I agree with Kiran. Okay, I see a lot of people are saying English. Let's see. Yeah, I mean, most of the people are saying English. So I'll go with English. No worries at all. Yeah, I'll go with English. Cool. And lastly, please ask questions, right? Because I want this session to be as interactive as possible. The more you will ask questions, the more you'll interact with me, the more fun you will have, and the more fun I will have teaching you as well, right? And the more you'll learn in the end. So it's a win-win for both of us. Cool. So now the things are done, right? The everything is discussed, and I want to ask you: are you all excited about this particular session as me? Just write it in the chat if you're excited, because I mean, this is how I teach, right? I'll constantly be interacting with you in the chat, and I would definitely love if you'll interact with me as well, because my camera is not open. I can't open it because I have a weak internet connection here, and this is the fun of having a Discord session. I can interact with you on chat. So are you all excited? Yeah, you can send in your emojis, your favorite emojis, and yeah, we can get started. Cool. Just let me do a few things here on my end. Cool. Just yeah, one thing. Just let me know if anything lags on my side because my internet is a little bit weak here, right? If it's not, then good. Cool. So let's start with traditional software development, right? Because at the end of the day, we are talking about how can we deliver products to the customers, right? How we can deliver software. So we are talking about the entire software development life cycle of things, right? And DevOps is again one of the methods to do that. But first, we have to understand how things used to happen previously. Like why did DevOps come into picture in the first place, right? So let's go in the past and understand how did traditional software development or software delivery looked like. So here you can see. Let me know if you want me to zoom in a bit. You can do that. Just a second. Uh, yeah, cool. So so traditional software delivery, right? Let's try to understand this. How did that work, and what were the things that used to happen previously? So who has in the chat heard of the waterfall model before? Let me know in the chat. Has anyone here heard of the waterfall model? Has anyone studied here? Had anyone studied this particular model in college? And if you have studied, what exactly is a waterfall model? Let me know. I mean, you can see the diagram in front of you, but what exactly is that according to you? Your definition of a waterfall model. I'm waiting if anyone is writing in the chat. Just wait for like 1 or 2 minutes. Okay, Kelvin is saying it's step-by-step process to build the product. Yep, that's going in the right direction. Describes the various phases of a SDLC. Yep, waterfall model. Okay, SDLC is basically software delivery life cycle, and waterfall model is one of the models that is followed in the software delivery life cycle. Cool. So a few people know here. That's great to know. So in the traditional software development, right, the waterfall model was being used, and this was sort of a very linear model, right? By linear, what I mean is, the stages were one after the other, like this. So you can see the diagram here, right? These are the different stages of a waterfall model, and that's how the software or the traditional software was built by the teams, by the companies who were using the traditional software development practices. So the number first stage was requirement gathering. They used to gather the requirements, that what is needed, what problem needs to be solved, and if what features are to be, new features are to be developed. Then once decided, then they used to go to the analysis phase. Analysis means they used to analyze the market, they used to analyze the data, whether the feature is needed or not, whether they are, because they didn't want to waste their money, they didn't want to spend extra money on something that is not required by the market, right? So the analysis phase used to basically give market research of that particular feature. Then the stage used to go to the design stage, where they used to design how you want to build the feature. Basically, it's the planning stage. So these three are, you can consider these three as the plan stage. So this was the planning stage of the particular feature, and then the main stage used to happen, which was coding. Coding the actual feature. Where developers used to work and used to code the actual features. And then came the testing part, where developers used to test the feature as well, right? And then the operations section, right, which was done by the ops team. So this is the highlight, right? In traditional software development, right, the developers and the operations team, these were the two main teams that used to work together, right? The development team was responsible for coding plus testing the feature, testing the new application code that was being written. And the operations team was fully responsible to deploy that particular feature onto the production server, right? The production server, which was visible to your end users. Cool. We understand till here? Nice. Now, the main problem was, right? The main problem was that, as I mentioned, the two main teams were the developers, the development team, and the operations team. In the traditional software delivery life cycle, or how traditionally the software was made, the developer team and the operations team were separated by a wall, right? My drawing is a little bad, so please bear with that. They were separated by a wall. And what do I mean by separated by a wall? Means there was no communication between these two teams. And by communication, I mean constant communication. So let me give you an example so you'll understand it a bit better. So just a second. There will be a lot of diagrams today, just a heads up, because I like to explain things using diagram. Cool. So let us see how things happen, right? So we have a developer here, right? You can consider yourself a developer here, and you have an operations person here. The developers are responsible for coding the things, right? The code, and the operations team is responsible for deploying, right? Deploying the new changes to the server. Cool. Now imagine that you are a company, right? Imagine that you are a part of a company and you are deploying a new version of an e-commerce website, right? Let us say this is your website. Let us say this is your website, and you want to deploy a new feature. You want to integrate a new feature into your website. Maybe that could be adding a nav bar, that could be adding a chat bot, or any new feature. You want to do that, right? That is the main goal. So what you did was basically did this particular process. You planned the entire thing. You gathered the requirements. You did the market analysis. You designed the feature, and now it's time to code, test, and operate, right? The operations part, the deployment part. These are the three things that are left. Cool. Okay. So you did that. Now the developers or the development team coded the entire thing, right? They added the new feature. They basically coded the new feature. So basically coded plus tested. These two things are done, right? And now they have this particular feature ready to be deployed, right? Now what happens is once the code files and the testing and everything is done, they will hand over the code files to the operations team, right? So that the operations team can deploy that particular feature into the production server. Now, what the deployment team will do, the operations team will basically review the things first. They'll review what changes needs to, they'll review what code changes are done. Then they'll basically deploy it to a production server. And this particular production server will be visible to the customers. Okay. Now you'll ask me, hey Kunal, what is the problem here? Right? I mean, everything is going seamlessly and the code is being written, it's being directly pushed to the operations team, and the operations team take that code and they are reviewing it and they are deploying it to the production server, and the customer seems happy. So what's the problem? The problem is this particular wall of communication that you're seeing here. I'll tell you how. So let's say that the code is written, right? For example, let us say the website is written in Python, right? You have written, the developers wrote the application in Python and they use Django as a backend, right? And anyone who has worked with Django before, or anyone who has worked with Python before, that there are a lot of packages that you needs to install, right? To run your application. By the way, I'm not seeing the chat right now. I have opened a few notes on my other monitor. But if you want to ask any questions, I'll refer to the chat in a few minutes after I explain this particular thing. And you can always unmute or write it in the chat and ping me. I'll see the questions afterwards. Cool. So if you have worked with Python, you know that there are a lot of packages and there are a lot of dependencies to the application, right? Now, once the because see, the developers who are developing the application, they know about all these dependencies, they know about all these packages that the application needs to run. But as soon as they hand over the files to the operations team, the operations team are not coders. The operations team doesn't know what are the dependencies to install, because operations team has a different environment where operations team has a different environment where they are testing the application to be deployed, and the coders or the developers have a different environment where they are developing the applications, right? So the operations team is unaware of the dependencies, of the packages, or what are the sort of extra things needed for the application to run, right? And and because of this particular wall in between, because of this particular sort of non-communicative way of working, developers team separate, operations team separate, the developers aren't able to communicate these particular things to the operations team. And you all can imagine what would happen. The operations team would have a really, really hard time to run this application in their own environment in the first place. I mean, forget about deployment. They won't be able to run it properly in their environment in the first place, because now they don't know the dependencies, they don't know the packages that are needed to run the application, and they are sort of in a deadlock, right? And there is no clear communication between the developers and between the operations team about what are these extra things needed to run the application, and that sort of creates this entire loop of confusion between the developers and between the operations team, right? And you can imagine this particular confusion happening in a really large organization, right? There will be a lot of time taken to deploy an application, to deploy a new feature. The customers won't be happy. So at the starting we had a smiley face, now we'll have a sad face because the customers gets, the features that the customers are getting are very late, right? So this is one of the main reasons. This is the very first challenge when it came to the traditional software development. I'll see the chat for a while if you are, in in par with me, if you are with me till here, or have I lost anyone here? Okay, were you are able to understand till here? What were the problems? Were you able to understand? Just let me know in the chat. Okay. Okay. I see a question here. Testing is related to manual testing and all those. Yeah. Yes. Unit testing, manual testing, integration testing. If there are different types of testing, right? So all the testing methodologies that you can imagine of, that we are talking about in a combination of that. Cool. Cool. So people are good with that. Great. So this was one of the main challenge, right? This was one of the challenge. Let's see what was the second challenge. Let me just first erase this jargon of things that I have drawn here. Just a second. Whoops. Yeah. Just give me a second, folks. Okay. Cool. Cool. Yeah, much better. Great. Cool. So this was one of the challenge, right? What was the challenge? Because of this miscommunication in between, right? The code that was given by the developers, operations team didn't know how to run that code, right? And this basically caused a lot of time to get the features deployed, and this basically caused a lot of confusion. The second problem, the second challenge, which was faced by the developers, I'm sorry, which was faced by the operations team, was in the traditional, because we are talking about the traditional software development lifecycle, the deployment process that was done by the operations team, it used to happen manually, right? Now, what do I mean by manually? Once, let us say this is the code file, right? This is the Python code file that is for our main website. This was handed over to the operations team. So what the operations team did at that particular time, when we are talking about the traditional approach, they used to take this file, take this particular code file. These can be multiple files. I'm taking a simple example, just take a simple example where you have code running in a single file. The operations team will take that single file. It will copy this particular file onto the production server, onto the main production server manually, right? This is the server, imagine. The operations team will just copy this particular file in the server, and they'll, update the configurations, you know, update the configurations manually, that too, and update any other things that are needed to run this application in the server. So everything used to happen manually. Now, when we are handling things manually, right? And just write it in the chat if you agree with me. When we are handling things manually, there is a lot of risk of human errors. someone in the operations team, let's say they just joined the app and they wrote a wrong configuration. And that wrong configuration, when deployed onto the production server, it crashed the production server. And if the production server is crashed, then the end user or the end customer will face downtime, right? Because now your production server is crashed. And then you'll have to again go through the entire cycle when the developers will write a fix for that. Then they'll pass it on the operations team. Then the operations team will again deploy the new thing to the to the production server. And again, we'll sort of have the same story. So you see how difficult is that. And this basically, one of the reasons is that it is prone to human error. And the second challenge in this particular approach, in this particular manual deployment approach, is deployment took a lot of time, right? And I think you can figure out why. Because everything is being done manually. You'll have to take the code, you'll have to update the configurations manually, you'll have to check the dependencies and stuff, and which was a challenge again we saw previously as well, right? So this basically took a lot of time. And again, new features, the development of new features, the release of those new features took a lot of time, and the customers aren't happy again. So we are sort of again in the same story, right? This was the second challenge that was faced in the traditional software delivery. Cool. Just let me. I'm going very slow. I'm just after explaining each thing, I'm seeing the chat if there are any questions. So I don't see any questions here. Cool. So this was sort of the challenge. Now let's go back to the slides. I hope you get the main crux of this. Let me just remove all of this. So all in all, the main point is that in traditional software delivery, the developers and the operations team were separate, right? And this particular way caused a lot of challenges. Let's go back to the slides. So we discussed this, there was a silo. Silo means isolation, the wall that we talked about, the wall of confusion. In technical terms, it is called as a silo, right? So if you'll search on internet the siloed approach, you'll end up on an article which will explain you about the traditional software delivery, right? So you can maybe search on the internet siloed approach. What exactly does that mean, right? So the siloed approach between the teams led to communication gaps, right? As I showed an example to you, right? And this in turn affected the entire delivery of the software. Long release cycles, as I mentioned previously as well, due to all this confusion, right? Due to communication gaps, right? Due to, let's say, manual deployment methods, due to lack of collaboration, because this particular wall symbolizes that there is a lack of communication between the two teams. They are separately operating, they don't have a communication between. So due to these particular things, the release of a new feature or a new update to the website took a very long time, right? And that was one of the main challenges in the traditional software delivery or development, if you call it that. A lot of manual processes, as I mentioned, manual deployment. So that was very time consuming and it was very much error prone, right? Because again, even if you are an experienced developer, even if you are very much experienced in the industry, you are a human at the end of the day, right? And humans tend to make mistakes. There can be any mistakes, and one such mistakes could cause could cause your server to crash or could cause downtime in your server. So there were a lot of manual processes in the traditional software development, and that basically know was a challenge, right? And limited collaboration, as I mentioned previously as well. So these were a few challenges, right, that happened when we uh, basically followed the traditional software development practices, right? Now now comes the interesting thing. Okay, one section is done, right? Just let me know if you have any doubts or if you're following along with me. Just if you could write a yes or a thumbs up in the chat, that would be great to know. I'll just pause here for a second and maybe drink some water as well. Okay, cool. Great, great. I see some thumbs up. Great. So now is the interesting part, right? Now we are starting the main part of our particular talk. The context was important, right? It was important for you to understand why did DevOps come into the picture in the first place, right? So let's talk about rise of DevOps, which was an answer to the traditional software development approach. So what exactly is DevOps, right? And this is a definition by GitLab. It's a very apt definition. So GitLab says that DevOps is a combination of software development and operations, right? So they are combining these two particular teams, and it is defined as a software engineering methodology, right? This particular word is very, very important. Software engineering methodology, because a lot of people confuse DevOps that, a lot of people say to me, hey, Kunal, is DevOps a tool? Or a lot of beginners especially confuse DevOps with a certain tool or with a certain software out there. No, DevOps is neither a tool, DevOps is neither a software. It's a method of doing things, right? It's a way of building software, right? It's a methodology that is being followed, right? Which aims to integrate the work of the development teams and the operations team by facilitating a culture of collaboration and shared responsibility. I'll explain this when I'll move on to the next slide, because I'll be going into DevOps in detail. But I think this definition is very apt, because what are we doing in DevOps is that previously, as I mentioned, the developers and the operations team, there was this wall of confusion in between them, right? Just let me erase this. Oops. Uh, Yeah, no worries. There was this wall of confusion in between them, right? The siloed approach that we talked about. So, what we are doing in DevOps is that we are trying to eliminate this wall, and we are sort of focusing on how a developer or how the developers team can constantly be in communication with the operations team, and the operations team can constantly be in communication with the development team, right? And we have already seen a lot of we have already seen like scenarios where problems arise due to this particular siloed approach. And I think now you will be able to see like how this particular DevOps methodology would help here, right? Would help to solve those particular challenges. And you'll see how it does right now. So this was the main aim of DevOps. It basically is a software engineering methodology that focuses on a culture of collaboration, collaborating between these two teams and generally all the other teams that are in the organization, and they both have a shared responsibility to deploy and manage and basically create new features for the software, right? For the software which is being given to the end customers, end users, right? So this is the main this is basically the main definition of DevOps. It's a methodology, not a tool, not a software. It's a methodology, right? So keep that in mind, please. Okay, so what are the key principles on which DevOps is based? Like let us see this. Just a second. Let me Yeah. So what are the key principles? So number one key principle in DevOps is automation, right? This is sort of the center point of DevOps, that each and every process that you're doing should be automated. We saw previously, right? We saw here that there were a lot of manual things that were being done by the operations team, especially by the operations team. They used to manually deploy the application code onto their production server, and that basically led to a lot of human errors, and that led to a lot of problems, that led to a lot of time for the software to be developed, right? So the main principle of DevOps, and this is one of the very important ones, is automation. How can we add automation in every aspect of the software delivery lifecycle, right? This is the one of the main principles. The next one is collaboration and communication, right? Again, how can we make the communication and the collaboration between the different teams seamless? Like how can we make them communicate more often during the process? So for example, if let us say these are the development team, this is the operations team. If you have a code, if the if development team has basically updated a new feature, they have created a new feature, they pass on the code to the operations team. So how can we develop a channel between the operations team and the development team so that the operations team can constantly communicate with the development team and understand what the code is all about? They can understand all the dependencies that the code needs. They can understand all the packages that the code needs. They can understand the extra thing, all the extra things. There could be n number of extra things that the code needs to run, right? Which was missing when we talked about the traditional approach, right? So the main aim of DevOps is to establish this seamless channel between the development team and the operations team. How that is done, we'll see a little bit later, but this is sort of the main aim or the main principle of DevOps, right? The next one is continuous improvement. This one is sort of, again, one of the important ones. How can we improve this particular process of software delivery, right? Now, in the traditional approach, you see, right, we have requirement gathering, we have analysis, design, and all these other stages. But important thing is, what about feedback, right? Let us say a developer has written some code here, right? And the officials or the CTO of the company is not satisfied with that code. What about giving feedback, right? Where is that feedback loop here, right? Because if there is no feedback, how can we improve the code, right? How can we develop new features? And what about taking feedback from, you know, the customers? Because customers are your main bread and butter, right? That's how you're earning money. So what about taking feedback from them, right? So DevOps was all about how we can continuously improve this particular life cycle, how we can continuously improve all the processes, how can we add a feedback loop, and that to a very short feedback loop. So let's say, I mean, you have added a feedback loop, and let's say, for example, on day one, your app is online and the customer has reported a issue, right? I've drawn this very bad. Let me just erase that. Yeah. Let's say you're a customer and you have given some sort of a review on an error, right? How much time is it taking for you to take this particular error and develop a patch in your application? Is it taking 100 days? Are you taking 30 days? Are you taking, for example, 10 days, or is it being done in 2 days only? This particular thing is very, very important for you to understand, right? The lower the time you take, the less the time you take to develop a patch for an error that has been reported by the customer, the more revenue you will gain and the more traffic your app will gain. The more number of days you take to develop that patch, to improve that particular thing, the your customers will keep on falling, your revenue will keep on falling, and you'll go bankrupt one day. This is the truth, right? And I hope you see why I'm telling you about this. And I hope you see why this is important, right? So how can you create shorter feedback loops, right? Let's say the customer has given you an error report, let's say, on day one, and you are able to patch it in 2 days. You have established that amount of automation, you have established that amount of feedback loop in your organization, that you have instantly communicated this to the developers. They include a patch, the operations team are able to deploy that patch to the production server, and your customer is happy again in just a few days, right? So you can see this is a major advantage, and that is what DevOps introduced to the picture, right? These are the four key principles of DevOps, right? These are sort of the four goals of DevOps. Why did DevOps came into the picture, and how did it solve the problems of the traditional software lifecycle? Cool. Let me just go onto the chat once again and see if I have any questions. Technology, but if it fails in one stage, we have to build from scratch. That's the failure. Uh, Kelvin, which point are you talking about here? If you could write it in the chat, that'd be great. But if you have any questions, just let me know. Or if you're able to understand, just please drop a thumbs up. That way I'll know, you all are still listening and you just haven't abandoned the stage for me. Great. People are listening. Cool. Okay, cool. So we talked about the different key principles of DevOps, right? This is sort of the main ones on which DevOps is based on. Now let's discuss what are the different stages, right? Because we saw previously that, let me just erase this whole particular jargon first. Yeah, this is sort of creating confusion. I'll lock this up. Yeah, and I'll erase everything else. Yeah, cool. Okay, so this was the waterfall model, right? We saw that everything happened iteratively, right? And there isn't a nice feedback loop. There isn't sort of, there isn't, this is sort of a one way thing, right? This is going in the this direction only. There is no going back from here, right? So, what are the different stages of DevOps and how did DevOps solve this? So, if you'll Google DevOps, right, you'll find this infinity loop, right? The very famous infinity loop of DevOps. And what this means is that software development or software delivery is a continuous cycle, right? Let me know if you are able to hear any background noise or something. Okay. So this infinity symbol means that software development or software delivery is a continuous loop. It will not stop anywhere, right? So let us see what are the different stages of DevOps and how did DevOps change the traditional, how is DevOps different from the traditional software delivery approach? So we saw a plan stage, right? In the traditional ones as well. We plan is, we code our, we basically code the feature or the new things that we want in our application. We then build it, the process of building your code or running your code, you can say. Then we have the testing phase, right? We are testing the code using some of the tools that are available. Let's discuss about the tools a little bit later, but these are the stages that you need to you need to keep in mind. Then we release that particular feature, right? We are deploying that particular feature onto a server, right? Release means, what does release means here? Release means that you are storing your new feature onto a platform like GitHub or Git, right? That is what release means, right? And then you're deploying your particular new feature or the new code changes that you did onto a server. Then there is an operate stage that we'll not talk about right now in very much detail, but operate means that you are constantly, uh, basically constantly deploying your code changes onto a server such as Kubernetes, right? Because right now, if you talk about of a software, there isn't just a single website or there isn't just a single service in your particular software, right? There are multiple services that needs to be managed. Now, who will manage that particular service? Who will keep in mind all the different things that are needed to manage these particular service? That is what we see in the operate stage, right? Don't need to worry about that. Just focus on what are the different stages that I'm talking about, right? After the operating stage, we have the monitoring stage. What is happening once you have deployed it on a server? Who is monitoring that? Who is constantly checking if there are any errors? Who's constantly checking if your application is not performing the way you want it to perform, right? So we have a monitoring stage, right? And let's say you discover a new error, you discover something that needs to be fixed, you again go to the plan stage, right? And the cycle keeps going on and on. So this is sort of the main stages of DevOps, right? This is how DevOps operate. I'll just, uh, delete everything here again. Let me just log all. I'll delete everything else. Yeah, cool. So these are the different stages of DevOps. And the question is, how do we do this? How each and every stage is done? So we have a lot of tools, right, that you can use. So, like for example, for storing your code, you have Git, right? You are version. So Git is a version control system. You might all be aware about this, right? So you are constantly storing your code in Git. So it's the release history or the version history of your code is always maintained. You're using some kind of build tools to build your application. Let's say your application is written in Java, so you are using Maven for that. Or let's say your application is written in Python, right? So you are using some kind of build tools that is built for Python, right? So all the build tools you can use in this particular stage. Then for testing, there are a lot of testing libraries as well. For example, we have Selenium. We also have Jest, which is by Facebook. So it totally depends on your tech stack, right? If you are using JavaScript, you'll basically use like something called as Cucumber. So we have Cucumber as well, right? So we're talking about implementation, right? Each stage has their own set of tools that we can use to implement that. So building part is done. We also tested our particular code. For release, we can use something called as Jenkins, and we have called as CodeShip. Jenkins is something that we'll use today as well. So you'll see an example of how Jenkins is used. But this is something that you use on the release stage. Then comes the deployment part, right? Where you're deploying your code, right? And here we are talking about a server, because eventually you deploy your code on a server, right? So here the tools that we use are called as Docker, which I believe you'll learn in your next workshop, right? If I'm not wrong, you are going to learn about containers and Docker in next workshop. So this is where we deploy our code, and we can also deploy it on cloud. So maybe AWS, maybe GCP. I think you are also going to learn about GCP in next set of workshops. So this is where you can deploy a particular code. And then when we are talking about operating, or operations, managing the multiple services or the multiple parts of your application, that's where Kubernetes comes. I'm curious to know who has heard of Kubernetes before, right? In the chat, if you can just write down who has heard of Kubernetes before. And you were always wondering, hey man, I mean, why do we need Kubernetes and what's its use, and where does it fit into the DevOps picture? Yep. I see a lot. K8s. Yeah, K8s is the short form of Kubernetes. If anyone of you doesn't know. Okay, Siddhant, that's funny. Yeah, cool. So people have heard about Kubernetes, right? And now you have got the answer. Where does it fit into the DevOps life cycle, right? Where does Kubernetes fit? And then we have the last stage, which is called as monitoring, where we are monitoring and we are constantly, checking whether our application has any errors or whether there are any bugs or sort of things. So we have a lot of tools for that. We have Datadog, Nagio, Splunk, and there are a bunch of tools. So if you open, one interesting thing I can show you right now. Who has heard of CNCF here in the chat? Let me know if you have heard of CNCF. Right? Okay, I see a few people. Right. So CNCF is basically Cloud Native Computing Foundation, right? It's basically an umbrella under which a lot of open source projects are there, right? And all of the projects that you're seeing here, right? This is the CNCF landscape website. I'll maybe link it down here. Yeah. So the CNCF landscape is basically where you can see all of the tools that are under the CNCF umbrella, right? So CNCF is an organization under which there are a lot of DevOps related tools, and you can see all of the tools that we discussed in the traditional that we are talking about in this particular DevOps lifecycle. The tools that are used in each and every stage of this, you'll find it in the CNCF landscape. Pretty cool, right? So you'll find, let me see, where's Kubernetes? Yeah, here you can see Kubernetes. You can see a lot of other tools as well. So the point is that if you heard about CNCF before, and if you're wondering that what is CNCF and what are all these tools, these are all the tools that are required to be executed and to be used in each stage in DevOps. Right? I hope you get the point. And I hope you are not confused, by the way. Second, yeah. So we talked about the different stages. So we have plan, code, test, packaging. We have also secure stage. We have release stage. Configure stages again. Other configure stages again. Other name of a stage between the operator and the monitor one. Right? But you'll find different diagrams with you know uh, different diagrams when you search on internet about DevOps. But the main crux is that this is a continuous cycle, and you'll always find the infinity symbol being associated with DevOps. Cool. And last is the monitor stage. Let me just see the chat once. Correction, not every single tool is in the landscape. There might be some mostly new tools which are not a part of the landscape. Yep, I agree. Thanks for correcting, Siddhant. So what Siddhant is saying that not every tool that we use in the DevOps lifecycle or in the is this particular infinity symbol at every stage is in the CNCF landscape. The tools that adhere to the cloud native standards, right? And this is something that I don't want to talk about right now because that will confuse you. So there are certain standards that have been set, and the tools which adhere to those standards, those are the tools that you'll find in the CNCF landscape. But a lot of tools that we use in this particular infinity symbol or all the stages of DevOps, you can find them on the CNCF landscape, right? That was the main point. Thanks for the correction, Siddharth. Okay, let's move ahead. Let us see where are we at. Okay. So we have discussed a lot of things. We discussed what is DevOps, right? We discussed what are the different principles of DevOps, and we also discussed what are the different stages that DevOps that are involved in DevOps. Now, what are the different practices in DevOps, right? How are the so practices are basically directly related to the principles. How are the principles of DevOps being implemented in real place? One way is the tools that are being used, and the practices are the second part of that, right? How are the principles being implemented in the first place? So the number one is version control. As I mentioned, all the code that you write has to be stored in a sort of has to be version. The versioning of that code needs to be stored somewhere. So you can use the tools like Git. You can use the very famous version control system is called Git, and you can store your code on GitHub or GitLab or certain things. But the main crux is that your code needs to be version controlled, right? And I hope that you all might be already aware of this particular concept, version control, right? Cool. The second part and the third one is what we are going to discuss today next, right? Which is called as continuous integration and continuous deployment and delivery, right? These are two separate things. I'll tell you how in just a few minutes. But CI/CD, this is one of the main principles of DevOps, right? That's how you are able to implement this entire life cycle of DevOps in a continuous manner, right? As I mentioned previously, right? This is a continuous cycle of building software. That's how the name comes: continuous integration, continuous delivery, or deployment. I'll tell you more about this in the next slide. The last two is called as infrastructure as code and monitoring and logging. Now, I'll not go into the depth of these two, but I'll just tell you that infrastructure as code comes into picture when you're talking about deploying your particular software onto a cloud platform. How can we automate that particular process, and how we can codify that particular process, right? How can we write a configuration file, or how can we write all the configurations needed for this particular software to be deployed onto a cloud server? Cool. That is where infrastructure as code comes into picture. And then last is monitoring and logging, that we already discussed, this particular stage of DevOps, where we are talking about how can we constantly monitor our applications and how we can constantly find new bugs and new errors, right? So these are the five basic DevOps practices that helps us to implement the DevOps in real life, right? Let me just check the chat once if I have any doubts, and we can go ahead and discuss about CI/CD next. I'll just have a short water break as well in between. Maybe you can write in the chat if you are following along with me till now. If you have any confusions, if you have any doubts, just let me know. Or if I'm going fast, and if you want me to slow a bit down as well, just let me know that also. Okay, Preetham is saying speed is okay. I hope everyone agrees with that. Because I don't want that after the session, a few people say, "यार मजा तो आया, कुछ अच्छा ही होगा." Kind of that thing. So I want that you are following along with me and you are learning at least something, out of this? Off topic, how you doing? Yeah, I'm doing great, man. What about you? Cool. So let's talk about CI/CD, right? The main interesting topic for today. And after that, we have a demo, right? So let's talk about CI/CD now. Let me just go here. CI/CD is pretty simple. Let's explain why. Just a second. I hope you're able to see the diagram clearly. Yeah, cool. So CI/CD is basically the main automation, right? Because every time we talk about DevOps, we talk about automation, right? How can we automate the process? So, what does this automation mean? What does this mean in real life? This automation turns out to be CI/CD, right? In technical terms, CI/CD, continuous integration. There are two parts to this, right? CI is continuous integration, and CD is continuous deployment, right? Let us understand this through a real world example. So imagine that you have your code sitting right here. You have built your application. You have, let us say, a Python code, right? You have built your application, and now you push these particular changes to GitHub, right? So you commit your code. Commit means you are saving your code, and you have pushed your particular changes to GitHub, right? Now, the first part, which is the CI part, continuous integration. You want, right? Forget about automation, forget about anything, right? You want that once your code changes are there on GitHub, once they are safe on GitHub, you want to build your code. By building your code means you want to create an artifact out of your code, right? As I mentioned previously as well, there are a lot of tools that are used here. For example, we have Maven for Java code. We might have some other tool for building a Python code, right? So you want to build your code, right? Once your code is built, you maybe want to run some unit tests which you have written, right? Forget about automation here, right? This is something that you want to do, right? You want to build your code, you want to run some unit tests, you might have some additional integration tests as well, right? This is something that you want to do, right? Now, how about we automate this particular process, right? As soon as you commit, as soon as you make a new change to your application, and as soon as you commit your code on GitHub, automatically your code builds the new changes that you made, right? Automatically your unit tests are run, and automatically other integration tests or any other thing that you want to configure here, they run automatically, right? In a continuous loop. This is called as the CI pipeline, the continuous integration. Continuously, as soon as a new change is pushed to GitHub, these particular stages run one after the other in a continuous fashion, right? This is called as the CI part of the pipeline, continuous integration. Cool. Now, after this interesting thing, after this continuous integration part of the continuous integration pipeline is run, your code is ready to be deployed. The main aim of the continuous integration pipeline of or the continuous integration part of the entire automation is to get the code deployment. Cool. Great. So now your code is ready to be deployed, right? And remember, everything is happening in an automated fashion now. Now let's come on to the CD part, which is continuous deployment. And from the name itself, I think you can guess what would this mean. So you are you may want to review the code, right? Once again, you may want to just you may want to deploy the code to a staging environment first. Okay, so let me just take you here. there are two types of environments when we come to deployment of a code. This is again a good to know thing. One is the staging environment, and one is the production environment. Interestingly, the staging and the production environment are the same, right? The environment of the staging environment, what do you mean by environment? The environment means that everything that needs to know that needs your everything that your application needs to run, all the configuration, everything that was previously being done by the operations team manually, right? You remember, right? In this particular part we discussed manual deployment, the configurations, the environment variables, or that extra thing that needed to be done to run your application in the deployment server, right? Everything that happens, that is called as an environment, right? Everything pre-configured. Now the staging and the product, there are two types of environment: staging and the production environment. Staging environment is where you can test your application same as the production environment. The only difference being the staging environment is not visible to the users, right? So you can, the environment are the same. The way your application will perform in the staging environment, it will perform the exact same way in the production environment. The difference being the staging environment is not visible to the end users or the end customers. The production environment is the one which your end users and end customers, it will be visible to them, right? So it's a very nice way to segregate your deployment into these two particular stages to just test your application how it's performing into the real world scenario, right? And this is the stage where you can find all the bugs, all the uh, all the basically bugs and any errors that is being, any errors that is being occurring, and you can basically forward that error to the development team, and they can again uh, develop a patch for that, right? So these are the two environments. Now you want that our application is automatically tested to the staging environment, okay, deployed to the staging environment. And once your application performs good in the staging environment, you then want it to be deployed in the production environment, right? And your production environment is the one that is visible to the end users. So this is the continuous deployment part of things, right? So now you see CI/CD pipeline is nothing but a continuous chain of events that occur one after the other. If one of the event fails, it will not go ahead. It will just stop here. And you know that at which stage the error occurred exactly, right? Whether the error occurred at the unit testing phase, for example, the tests aren't written properly. If the tests fail, that means there is an error in your code. You can fix that. If, for example, your application didn't perform well in the staging environment, the automation will stop there, right? And the new feature will not be deployed onto the main website, right? Now you can see the advantages here. If a feature is buggy, if a feature has bugs, that particular bug will be caught in this entire pipeline without even being deployed onto the production server, right? This will reduce downtime because now your feature, the buggy feature, will not be deployed on the production server and the users will keep using your website. Once you have discovered the bug, you can fix the bug again, you can commit the code, the cycle will run again. If everything passes, then the right feature will be deployed onto the production server and your end user will be happy again, right? Cool. So this is the entire, this is basically the automation that a lot of people talk about. CI/CD pipeline. This is the main concept of CI/CD pipeline, right? A lot of people complicate things a lot, but I've tried my best to simplify it in a very nice manner, right? I hope you got the point. And this is what we'll be seeing, a very basic example of a CI/CD pipeline we'll be seeing just now in a demo, and I'll show you how does this look in real life. But I just want to see the chat once and see what's going on, and if you have any doubts or anything, just let me know. Okay, I see a lot of things are being happening here. If you're still with me, let me know with a thumbs up. Uh, I'm just seeing the chat. Okay, Tess, Omi. Okay, I hope I'm pronouncing your name correctly. Tests are written in GitHub, but where? Is it GitHub Actions? Could you please clarify? And what is linting in GitHub? So the tests would be written in your application code, right? And I'll show you how the tests are written. I mean, I'm not sure like writing a test right now, but I have a code in which I wrote a very basic unit test. So the test file is included with your code base only, right? You just need something to run those tests automatically, right? For example, you have a Python file, right, which is called as I'll just give a clear space here. For example, you have written your tests of your application and you have your test file as test.py, right? And if you have worked with Django before, Django is basically a framework of Python through which you can develop Python backend applications. There is a simple command to execute this test: Python manage.py and test. So this is the command. If you run it locally on your terminal, when you have the code locally in your terminal, this will execute the tests that you have written in this test.py file, right? Now, you don't want this particular command, you don't want to run automatically, right? Let's say you are lazy, right? For just for fun. Let's say you don't want to run this manually. You don't want to execute this manually on your own. You set up an automation that does this automatically. It will run the test for you, and if the test fail, that means there is an error in your code, right? So the test file will be included with your code base. And could you please clarify? And what is linting in GitHub? I'm not really sure about that, to be honest. I think linting is related to formatting of your code, basically the lines of code. If anyone in the chat, if you are familiar with the concept of linting, please you can answer Omi's question here. I'm not really sure of that. Sorry. Okay, cool. I think people are here with me. So let's move on to the demo. Right? Who's interested for the demo, by the way? I know you've been waiting for this since a long time. We've covered a lot of theory today. Yes, demo time. Yeah. Yeah, I just hope that the demo doesn't break because that usually, tends to happen. Cool. I'll just close this. Yeah, please, demo gods, be with us. Cool. I'm really not sure why I closed that. Let me just open it again. Yeah. So let us see what we are building today. I mean, I will not build this entirely from scratch. I just want to explain the concept of CI/CD and how does it look in real life, right? So I've done a little bit of cheating and built this previously before the session. So please forgive me. But I just wanted to show you the concept, and I'll definitely show you how the pipeline is getting executed. Cool. Just a second. I'll scale this up a bit so you can all see. Great. Just a second. Yeah. So we are building we are seeing a simple CI/CD pipeline here, right? So what does it do basically? So this is you, right? You have committed a new change to your particular code base, right? You used Git, you committed a new change to your code base, and your code is stored on GitHub, right? That is what we studied in the basic concept of CI/CD, right? Now comes the main automation part. So we want an automation, right? Forget about any tool, forget this I've written Jenkins here, right? Forget for a moment. We want some kind of an automation to come into play here and do the following things. Firstly, we want it to run the tests. I've written a few tests in my application. I want this automation to run that. Cool. The second thing we want our automation to do is pushing the Docker image to Docker Hub. Okay. Let me just, go a little step further here and explain to you what is a Docker container and a Docker image. I'll not cover this in a very much depth because I know that you have a workshop, I think next one, I believe, on this particular concept of containerization and dockerization and all that fun stuff. I'll just cover the basics so that you can, understand this particular process and you can understand the terms that I'm talking about. Okay. So there are two things when it comes to Docker. Okay. The number one is a container. I'll explain this in a very simple manner. Okay. Don't worry about that. Not going into much details. The first thing is the container, and the second thing is the image. Cool. So a container, right, is basically, consider a container is a box, right? This is a box. And this box is sort of an environment, right, which contains all the code files plus the dependencies plus the packages that are plus some extra things that are needed to run your application. Cool. Interesting part to know is this particular container or the environment runs inside your operating system. This is your operating system. For example, you are using Windows or using Mac OS, or basically you are using Linux, right? These are the three ones, right? So this particular container, this isolated environment is running inside your operating system, but it is independent of that. So it's basically very isolated. This particular wall that I'm, this zigzag wall that I'm building, it depicts isolation. So anything that your OS is doing doesn't bother the container. Doesn't bother this particular box, and anything what is happening inside your box doesn't bother what is happening inside your operating system. So these two are independent of each other, right? And this particular box is what is called as a container, right? Okay. Now, I'll not go into details of like how the container is different from a VM, because if you have used a VM, you'll see some similarities here, right? If you have used VM before. I'll not go into the depth. I'm just explaining what a container is so that you can understand when we'll use it in the pipeline, right? So this is basically a container, right? Everything that your code needs to run is inside an isolated environment, and your code is running here successfully. And this is basically isolated from your operating system. This is what a container is. The second concept here is image. Image is basically the recipe of creating a container. In an image, you define what the internal environment of a container should look like, right? It specifies everything, the code, the dependencies, and everything that we talked about here. That is what we specify in an image. What code you want to run, what are the packages you want, what are the dependencies you want, right? And what are the additional configuration you want, right? That is what we define in an image. Cool. So this is basically the difference between a container and an image. And when you run an image, when you run an image, it forms a container. I think that's the basically the meaning at the end of the day. When you run an image, it will start a container, and the container will start your application basically. And I hope you understand the concept of container application. Let me know in the chat if you have any doubts. I'm not going into the depth of this because I know you have a workshop and this particular concept will be explained in very much detail there. I hope so, right? And I've just explained it in a very, very simple manner, just an bird's eye view of what a container and image is, just so that you understand what we are trying to build here. if you could just write a thumbs up or any reaction or an emoji in the chat, that will help me to, see if you really understood a container and an image concept. Okay, Siddhant is very much trying his best to confuse people. Don't listen to him, folks. Don't listen to Siddhant. Okay, cool. Yeah, jokes apart, I love you, Siddhant. You're a great friend. Great. So, what does a CI/CD pipeline do? Right. The number one is we are running our tests. Right. The second thing, we want our image that we created, which will define how we create an image. Previously, we'll define it with the code. We want the image to be pushed to Docker Hub. So Docker Hub is basically like GitHub, but it's for Docker images. It's for container images, right? This is where you are, basically storing all your container images. Because container image is sort of an artifact file, right? So we want, just like your code, just like we want the code to be always be pushed to GitHub, we want the container image to be automatically pushed to GitHub and be stored there, right? For example, for future perspective, right? If you want to check your image or if you want to do something with that, just for future safety. So this is the second thing. And the third thing we want to do is we want to run the Docker container. And this is basically the deployment part. So when we are running the Docker container, that comes in the deployment part, right? If you remember the diagram, in the deployment section, you can see Docker here, right? So Docker is one of the tools which you can use to deploy your application on any server, right? And the server, what is our server, right? Where are we deploying the application? In my case, right now, the server is local. So I'm deploying the application on a local host. This can be a cloud server like AWS, like GCP as well, right? Or keeping it simple, I'm doing it locally. So our application will be deployed locally and we'll be able to access it on local host and some path here. Cool. So this is what we are going to do. And this is what I'll show you. And the main important part of this particular thing is the automation, this particular task. The tool that we're using here is called as Jenkins. Oops. Just a second. Lock this up. Yeah. The tool that we're using for doing this particular automation and basically building the pipeline, building this particular automation pipeline, this is called as Jenkins. And if I just quickly show you, so for anyone who doesn't know, Jenkins is an open source tool. It's an open source automation server that helps you build such pipelines, and it's an industry standard. A lot of companies are actually using this particular tool. And if you ask me, hey Kunal, what are the different other tools that we can use for the automation? You can choose any tool, right? There are a bunch of other tools that you can choose. You can basically, choose. I think someone mentioned GitHub Actions, right? So GitHub Actions is specific to GitHub. If you want to set up a CI/CD pipeline and your code is stored on GitHub, then you can use GitHub Actions to set up this particular automation. You also have something called as Travis CI. Travis CI, right? There is also Circle CI. I mean, you can, if you just go onto the internet and you can search CI/CD tools, you can find a bunch of tools out there, right? We also have GitLab. GitLab provides CI/CD tool, integrated to their particular platform. We also have Argo CD. Argo CD is something which is little bit advanced, and it enables you to deploy your application. The server, this particular thing, the end part of your application where your application is deployed, that will be on Kubernetes if you use Argo CD, right? So that is something which is called as GitOps. I won't go into that and forget if I even mentioned about it. I don't want anyone to get confused here. Cool. So there are a bunch of tools. that you can use. But today we'll be doing Jenkins because it's pretty simple to get started with Jenkins. And if you want to try this on your own, you can just head over to this GitHub repo and I'll link it down below. All the code you'll find here. If you want to try this and if you want to try something new, you can replace Jenkins completely and you can try with GitHub Actions, right? You can do this automation with GitHub Actions. Okay, I think we have talked enough. I'll just show you what it does in real life. Cool. Let me get my keyboard here. Okay, cool. So this is our VS Code. Let me know if you want the font to be a little bit bigger. I can do that. So this is the code. I'll quickly show you. This is basically a Python application, right? This is a Django application, Python to-do list, Django to-do list built with Python. If I just show you how you can run this particular thing, if I do this right now, and if I just go here, so this is basically the application, right? You can choose any application you want. I have chosen a Django to-do list, pretty simple one. You can add your to-do items. Let's say, hello. You can add your to-do items. You can cut it. If you have done this, you can delete the item. And this is the simple application that I'll use in my case. Cool. Okay, just a second. Yeah. So the first thing that okay, let's replicate a real life scenario, right? You are a DevOps engineer. Consider yourself a DevOps engineer, right? And this is your project, right? This is your end project that you want to deploy and you want to basically set up a CI/CD pipeline for this, right? So the first thing that you should do is testing your application locally, and that is what we did right now. I'll not go into the depths of this because there might be a lot of people who don't know Python, but this is what we are doing. We are testing our application locally, whether it runs on our local server or not, right? That is what we are doing right now. So it works perfectly fine. Now, as I mentioned previously, everything that we want Jenkins to do, I don't know why I am closing this again and again. Yeah, everything that we want Jenkins to do, we want this particular automation to do, we'll first test it locally on our system by ourselves, right? Doing everything manually, right? So when we do the automation part of things, you'll understand it even better, right? So we first tested our application, right? And now we want to run the tests. So this is basically the test file I've written. I'll not go into the code details and stuff, but we'll just see if the test runs or not. We'll do manage.py test. So the tests are running successfully. All the 4 tests ran and the result is okay, right? Cool. So the test is run. What is the next thing that we want it to do? We want to run the container. We want to run the Docker container, right? Pushing the image to Docker Hub, that will directly see when the automation will happen, right? It's just a simple command. But let's run a container. Cool. So, okay. If you remember, I mentioned there are two things when it comes to Docker, right? Docker is a tool that helps us to manage the containers. So number one is the container, which is the running part of the application. And the second is the image, which is the recipe of a container. What does a container do? What are the code that we need? What are the packages, dependencies? Everything that we need is configured in an image. And how do we build an image? We write a Docker file for this, right? So there is no extension, nothing for this. It's just, we just write Docker file. That's it. And here we define what our container or what the image for our container should look like, right? Again, if you are getting confused here, just let me know in the chat and I can definitely repeat this because I know many of you might not be aware of the concept of Docker containerization. If you're getting confused, just let me know and I'll tell you again. Cool. And I'll just give you an overview, okay, what is going on. So as I mentioned previously, right, the container is an isolated environment, right? And everything inside your an environment is basically, what is an environment? Everything that needs your everything that is needed by your application to run, right? That should be there in your particular environment. Cool. So in your container, sorry, in your container, container, the first thing that we want is Python to be there, right? Because our application is written in Python. So if there is no Python in our container, how would our application run, right? So here we have specified a Python image, right? Now, again, I don't want to confuse you, but this is the format of how a Docker file is written. We first give it the name of the container image that we want our environment, that we want the environment to look like, and how we want an environment to look like. So we want Python to be pre-installed. This particular line means that Python will come pre-installed in our particular container. Okay, just understand this right now. Cool. Then what we are doing is we are creating a new directory inside our container, because as I mentioned, a container is a separate virtual environment. You can consider it a virtual machine for now. A container is different from virtual machine. How? You'll cover that in the next workshop. But right now, for just simplicity purposes, consider it as a virtual machine running in your system, right? So you have installed Python in that virtual machine, right? You have installed, sorry, you have created a new directory called as app in your particular container, right? And forget about these variables, just forget about them. What you're doing now is you're installing pip, right? So pip is the package manager that we use with the Python application, right? If you have worked with Node.js, you know what is the package manager that we use with Node.js? Just let me know in the chat. I'll test your knowledge with that question. Just type it out in the chat if you have worked with Node.js before. What is the package manager used with that? Yep, Pritham is first. NPM. That's good. So just like how we use npm with Node applications, we use pip when we work with the Python applications, right? So we definitely want pip to be there. Why? I'll tell you just now. When we Okay, so you have heard of Node modules, right? When we are working with the Node.js applications, because I know a lot of people would be, knowing about Node.js here. And when we are working with Node.js application, there is a file called as node modules, right? And node modules is where all the modules of your particular application live, right? Whatever module, whatever dependencies or packages that your application is using, all those particular modules or packages live under the node modules directory, right? The same way, in a Python application, everything lives inside a requirement.txt file. All the modules, all the packages that are required for your application to run, the dependencies, those are mentioned in the requirements.txt file. Cool. So evidently, right, we would want this particular requirement.txt file in our isolated environment, right? So in this particular step, you can see what we're doing is we are copying the requirements.txt file from here to the isolated environment inside our container, to the apps folder. That way, we'll have the requirements.txt file. And in our requirements.txt file, we have all the packages that are needed by our application to run, right? And then the next step, what we're doing is we are running this requirements.txt file. The command for that is pip install -r requirements.txt. And that is how you are basically installing all these packages inside your isolated container. Cool. I hope this makes sense, right? And this is sort of the phase where we are creating the environment for our application to run, right? We haven't run our application till now. Inside our isolated environment, we are just we are just creating the necessary environment, and we are just installing the packages that our application needs to run. Cool. Now, if you remember, I told you all the code files are also here in your particular container environment. So what we are doing here in this step is we are copying all the code files. We'll definitely be needing that, right? There is no surprise here. We are copying everything into this apps folder. Now comes the interesting part. I'll have to, explain this to you in a little bit nice manner. I know this might have become a Docker lecture or a containerized lecture, but it is important for you to understand, right? Then only you'll get the idea for that. Let us say this is your operating system, right? And this is basically your code files and everything, and your container. Now, as I mentioned previously, the container is an isolated environment. Whatever is going on inside your container, your operating system doesn't know of that. And whatever is going on inside your operating system, your container may or may not know of that. Cool. So, what we want is that, because by default, as we previously saw, right? By default, a Django application runs on port 8000, right? So, if we remember previously, when we executed the Django application, it was running on localhost 8000. And localhost, we all know, is the local server that is running in our operating system. Cool. Now, if our application is running on port 8000 of our container, our operating system doesn't know that whether something is running on 8000, because this particular, there is a wall in between, right? These particular two environments are isolated from each other, right? So what we are telling with this particular command is, please expose the port 8000, so that whatever is running inside your container on this particular port, which is essentially your to-do list application, your operating system will know of that, right? This particular port is now exposed to your operating system. So your operating system will show you, okay, something is running on port 8000. Cool. That is what we are doing here. And this is the command that we are writing, right? So this is the same command that we executed just now, python manage.py run server, and we are again, giving it the URL, or the sort of the port that we wanted to run on. So python manage.py run server, the same command that we are typing. So this is sort of how the container will look like, right? This is the recipe for a container. Now let us see how does this happen. Right, I'll execute it again. Right now we are focusing on doing everything manually. Right now we don't have any automation setup. I just wanted to show you how things are done manually, and then we'll move on to the automation part of things. I'll open my terminal right now. Okay. So if you have used Docker before, you can check Docker ps as the command to check all the running containers. And now we want to build a new image from this particular Docker file. So the command for that is docker build -t. -t is basically tag, so you can give it a name. Let's say demo app, right? And dot means that you're giving it the location of the Docker file, because it will build the image according to what you are defined in the Docker file. Cool. Let us execute this command, and it is basically executing all of these particular steps one by one. It will create the necessary environment for you all. It is executing again and again. Everything is being done. And now if you search for Docker images, you'll see this particular one. So demo app image latest. This is the Docker image that it has created. Now that we have the image, we can run the container. So I'm sorry. So the command to run the container now, and I'll explain it right now. Docker run -dp. I'll just admit this p 1000, and what was the name again? I forgot the name of the image. Docker image. Whoops. Yeah, this was demo app latest. Cool. We'll do docker run -p. I'll explain this command right now. Don't worry. Demo latest. This was the name. Why am I forgetting the name again? Okay, images. Demo app. Okay, demo app latest. Demo app latest. Cool. So what does this command do is, docker run is the command that we give for running a container, right? And minus p is basically a short form of port. Okay, so what we are doing is, sorry, 8000 is the port on which our application is running inside the container, right? What we want to do is we want to map that particular port with the 8000 port on our local host, on our operating system, right? This can only be done if you have exposed this particular port, right? For example, let us say you have written, some other port here. Let's say you've written port 1234. So you'll have to write that port here. So what it will do is it will map that particular port which is running inside your Docker container with the port of your local system. So that whenever you're doing localhost port 8000, it will open whatever is running on port 8000 that is running inside your container. If this makes sense, just leave a thumbs up below. This can be confusing if you are hearing this for the first time, if anyone is hearing this for the first time, right? So like execute this command. So our application is running, right? And it is giving the same thing as it showed when we ran the application locally. And you can see we can now access the application on localhost 8000. Yep. So the application is running on local 8000. And you can also see if I do docker ps, so you can see a container is running on 8000. Like there is a container ID. So every container that runs, it has a unique ID. It has a name. It gives the command that is being executed when the container is booted. And then this is the port. So this particular port, it is showing the mapping of the port that we did. Right. Cool. So the bottom line is our application is deployed on Docker. This is what it means the application is deployed on Docker. It is running as a Docker container. And we can do anything on this and it will execute perfectly fine. Cool. Okay, let me just stop this particular container. Great. Okay. Awesome. So now we have done all these steps manually, right? Let us now focus on the automation part of things. Let me take you to Jenkins now. So this is the main dashboard of Jenkins. I have my Jenkins is already running locally. Let me just log in to this dashboard. Okay, so this is for anyone. Let me know in the chat if you are hearing the Jenkins for the first time, or if you have heard of Jenkins before, or if this is your first time hearing about Jenkins or even working with Jenkins. Let me know in the chat. Okay. A lot of first timers. Nice. Okay, Siddhant, I believe you. Cool. So a lot of people are seeing this for the first time. Great. Glad to know. What is the importance of 8080 port? Like why mostly port 8080 is as default? That's an interesting question. I'm not sure about that. But for Jenkins, the default port is 8080, right? I'm not sure what's the importance of port 8080. Maybe Siddhant can tell you more about that, or anyone in the chat. Yeah, it's just a popular port. I mean, port 8080, port 3000, port 80, and even port 8000. These are some of the famous ports that are used for applications. I'm sorry. Cool. So, okay, I see a lot of people are seeing Jenkins for the first time, so I'll go slow here. So this is basically Jenkins, right? This is the main dashboard of Jenkins. Here you can see all the pipelines that are getting executed, right? And if I delete them, I'll show you. If I just delete this, if I just delete this one as well, whoops, it will take you to the main UI. Okay, so this is the main UI of Jenkins. This is how it will look fresh to you when you'll open it, when you log in it. How you can set up Jenkins locally, I will leave a few resources at the end of the session, so you can do that, right? But this is basically what Jenkins looks like. Our task is to create a job. A job is basically a certain task that we want to create. right? Or a project, right? Let's simplify this. We want to create a project, right? And here, when you open this particular thing, you'll see a bunch of options that you want to create, right? And now we are studying as we are studying CI/CD pipeline, so we'll select the pipeline option, right? Let me give it a name. Let us say, Gate Smashers. Cool. And we select the pipeline option. So what is pipeline? Pipeline is orchestrates long running activities, right? Forget about everything else. I don't want to complicate things. Orchestrates long running activities. That is the activities that run one after the other, right? That is what a pipeline means. That is what we studied previously as well, right? So that is what we want to create using Jenkins. Let's click OK. So this is basically the configuration of our pipeline, right? And here you'll see a bunch of options that you can explore on your own. You can watch a YouTube tutorial if you want to learn Jenkins a bit. But the important thing that we'll configure right now is pipeline script. Okay. Now there are two ways that you can work with Jenkins. Number one is using the UI that I'm showing you right now. The second part is using a pipeline script and writing a script, right? So right now we'll use a pipeline script and I'll show what does the pipeline script does. And in the pipeline script, what we are doing is we are just defining the different stages of our pipeline, right? What does our pipeline look like? What are the different stages that our pipeline should execute one after the other? That is what we define in the pipeline. That is what we define in a script. And just as the syntax for creating a Docker file was just simply, writing Docker file, no extensions. For writing a script of Jenkins, we use Jenkins file, right? And the syntax for writing a Jenkins file, if you have worked with JSON, it will look pretty similar to JSON, but it is not JSON. It is called as Groovy, right? So Groovy script. This is sort of the syntax that Jenkins file uses, right? You can learn about this particular syntax if you want. There are a lot of tutorials, but just so you know, Groovy is the language, the scripting language that a Jenkins file uses, right? If you want to write a pipeline using a sort of a codified manner, right? Now, I'll not explain each and everything here. I'll just explain the stages, right? The different stages, so that you can relate with me easily. Cool. So what do we want the pipeline to do? The first stage is we want to run tests, as we mentioned, right? So in this, what we're doing is we're executing a simple bash command. What we're doing is we are doing pip install requirements.txt. That is, we are downloading. Sorry, we are uh, sort of installing all the packages that are needed, right? And then what we are doing is we are executing a Python command to run the tests. If you remember, this is the same command we ran when we ran the test locally, right? The v3 flag is for verbosity. I'll show you the difference. Let's see. So Python manage.py test, and if I do v3, so it will just show you a little bit more information about what are the tests. What the verbosity. We are increasing the verbosity of the logs that it produces, right? If you run it without verbosity, it will just give you okay. Ran 4 tests and the output is okay. But if you run with v3, or there are other two modes, v1 and v2, it will show you a little bit more details of what were the tests that ran, right? So we want Jenkins to do the same, right? Let's just say you want to basically store these particular logs somewhere, or you want to see the details of the tests that are being run while the automation is going on, right? So that is why we have configured verbosity in. That is why we have used this v3 flag here. Cool. So this is the first stage. The first stage is for running the tests. So Jenkins will simply execute these two commands and it will run the tests. Cool. The next command is building a Docker image, right? So this is something interesting that we're doing. So Docker build -t, and the name we are giving is to the Docker registry. Okay. So again, I'll have to divert a little bit here. So this is the interface of Docker Hub, right? As I mentioned, Docker Hub is where we store our Docker images. And here we create Just like in GitHub, where we create a repository to store our code, in Docker Hub, we create a repositories to store our images. Cool. And for this particular workshop, I've created a new, uh, basically, Docker image repository. I know the spelling of Hoogly is wrong here. Please apologize. Please, I apologize for that. I did not see it in the first place. But the main point is that I've created a new repository here, and here is where all the Docker images related to our project will be stored. Cool. So what I'm doing here is I'm building an image. I'm giving it the name of the registry variable, and the registry variable is set with this particular value. vkunal is the name of my Docker Hub account, right? And cncf ugly is the repository name that we want the image to be pushed at. Cool. So I'm giving it the registry name, and I'm also giving it the commit hash, because as I mentioned previously, right, we'll be committing something to GitHub, right? We'll be doing some new changes to GitHub, and we want that particular change to reflect onto our main deployed website, right? And how can we track basically what commit did what changes, right? And which particular deployment, or which particular, basic, yeah, which particular deployment is related to that particular code change. So I have included a commit hash. That commit hash is basically the commit ID that we'll do, that will automatically be generated here, right? When we'll execute this, you'll understand it a bit better, in a bit meta manner. Cool. I'll just speed things up I'll speed things up a little bit because we have been running for a long time, and I'll respect everyone's time here. So the third step is we are pushing it to Docker Hub. Again, a simple command for that is Docker push, and we are again giving it the same address of the registry and the commit hash. That is the same image, and this is the same image that we build the Docker image. We named the Docker image, and this is the same image that we are pushing it to Docker Hub. Cool. And lastly, what we are doing is, which is the part of continuous delivery, we are running that Docker container again using the same image, right? And the command that we used is the same that we used when we ran the container locally. Cool. Now I hope you're able to relate with how things are done manually, and we are just automating this process. And for that automation, we are using Jenkins, right? And everything we have written in a Jenkins file. Cool. Let's go back. So what we want is, because I have already committed my Jenkins file to the GitHub repo, I'll directly configure Jenkins to take that directly from my GitHub repository. So source code management will select as Git, and now here we'll give the repository URL, which is this one. And we'd want some credentials so that Jenkins is able to authenticate with GitHub. I'll not maybe I can show you like where are the credentials stored, just for fun. So if you go to the dashboard, you go to manage Jenkins, you go to credentials. Here are the credentials that are stored. So I've given it two credentials. Number one is the GitHub token, that there is the GitHub access token, so that Jenkins is easily able to authenticate with GitHub. And the second one is the Docker Hub, because you see, at the second last step is you are pushing it to Docker Hub. So how does Jenkins know? How is Jenkins able to authenticate with Docker Hub, right? This because of this particular token. So you can create that particular token on your on your Docker Hub, and you can do that on your GitHub repo, and then you can store it on your Jenkins server, right? And that's how Jenkins will be able to perform some operations. All about to no, nothing is visible here, man. Great. So I've given it with my, the username and the password which I'm using to authenticate, right? And I'll again mention the branch, because we want the Jenkins file is basically stored in our main branch. So we'll give it the branch here, main branch, and that's it. And this is basically a script path. I'll leave it as it is by default, because my script is residing at the root directory here. So I don't want to change anything here. And we'll just hit save. Yeah, that's it. Our pipeline is created. Now, how can we test it? I'll show you a very interesting thing now. Okay. Let's clear things up, and let's run our application once on our local server. Okay. So this is an application that this is how it looks like. What if I want to create, basically I want to change this particular heading, right? Let's change this heading. Let's say, okay, I'll close this. I close my local server, and let me just navigate to this particular file. I think it's in templates. Yeah, this is the heading. So let's just see. What should I write? CNCF Hooghly. Yeah, shout out to CNCF Hooghly. Cool. This is what I changed. Right now, if I go here, I just close this. Git status. So we have changed the index.html file. Right. Our code is already on GitHub. We have made some changes, and now let's commit these particular changes. Right. This is the real world scenario on how you'll work. So I'll commit these changes. I'll add everything to it. I'll make a commit. Let's make a nice commit so that it's visible in the Jenkins logs. So let us see update heading to CNCF. Just like that. We have committed, and then let's push the change. Cool. So now, oops. Close this. Let's close this. Yeah. Anyone is saying something?
Excuse me, Kunal. Actually, we have some time constraints. So can you wrap it up a bit fast?
Yes. Yes. Absolutely. Absolutely. I'm just at the end of the session. Sorry for that. Okay. Cool. So now we have committed the code to GitHub, right? You can see the new commit here. Let me just show you. So we have the new commit is heading to CNCF. Now what we want is to execute this particular pipeline, right? Let me just hit build now. So if we go here, if you see the console output, we can see what Jenkins is actually doing. It will automatically execute all the stages that we have, defined in the Jenkins file, right? It will automatically do that. It is, taking the code from GitHub. It has, it's doing its thing. We'll just wait for it to get complete. Jenkins builds takes a lot of time. Come on, let the demo gods be with us. Let me see if I'm doing anything wrong here. In my opinion, it shouldn't take that much time. Yeah, interestingly, let me just see. Maybe let's just execute this again. Yeah, let's just check once again that we have set up everything. Yeah, nice, cool. Jenkins file is there. Let's hit build again. Interestingly, it's taking longer than expected. Okay, the first stage is done. Yeah. Cool. Now it's getting a few things done here. Okay, current context Docker Linux is not found on the file system. Well, if a live demo doesn't crash, it isn't a live demo, right? Let me just, I know the fix to this. Docker context use default. Okay, now I think it should be good to go. Let's execute this again. I think now it should execute. Yeah, let us see what it's doing. It's executing right now. So everything that we defined in the pipeline, right? So it first Jenkins read that we have a new commit, right, heading to CNCF. It basically fetched that particular commit. Then it ran pip install requirements.txt. It set up, basically it set that particular environment for our application to run. It then ran all the tests. So you can see all the tests being run here, and verbosity was 3, so we can see the logs of all the tests that are being run. After that, the tests were okay, and then we built a new image. So you see the commit, see the commit hash here. This is the new commit hash of the new commit that we did, right? After that, it built the image. Cool. After that, it basically is pushing the image right now to Docker up the new image that we created with this particular commit hash. It's pushing it right now, and after the image has been pushed, yep, it's been pushed. It will run the Docker container at last. Okay, so Docker run with the same image that has been pushed. So now, technically, if it's Docker PS, our container is already running, right? And if we do localhost 8000, you should see our new changes deployed on the main server. Interesting, right? If this seemed exciting, just drop it in the chat. If this was exciting to see, just let me know it if this was your first time executing a pipeline and it was exciting to see for you all, right? So the code changes are there, and if you see Docker Hub, if we reload this tab, you see the new image is already pushed here. So automation is pretty interesting, and this is sort of the main crux of a CI/CD pipeline, right? This is sort of what I wanted to show you. Cool. I think the demo is done, and I think you all are able to, understand what a CI/CD pipeline is, the basic crux. We covered a lot of things today. We covered, the basics of DevOps. We covered the principles, key principles of DevOps, core concepts, and the practices of DevOps, the different stages. And at last, we saw how a pipeline looks in real life. You can have this repository. Yeah, you can scan this particular QR code if you want access to the resources. I've collected a bunch of them for you all, just to, if you want to learn more. And I hope my pace was good, and I apologize for taking a lot of time. I know we are way ahead of time, but I really hope that you learned at least one thing new, the same thing that I mentioned in my shorts video. Yep. Thanks again for attending, and I hope you learned something new.
Thank you. Thank you so much, Kunal, for joining us. It was really an amazing, insightful session.
Okay, we can start the quiz, I guess.
Okay, here's the first question. What does CI/CD stand for?
ये अभी कुणाल ने थोड़ी देर पहले बताया था, guys. You need to answer this.
And time's up. Um, okay. So second question, 59% got correct. Advanced is here. Which of the following is a popular tool for implementing CI/CD pipelines? Docker, Git, Jenkins, Kubernetes. I guess there was a question error with this question. What does continuous deployment CD automate? Code compilation, testing, deployment to production, writing code. Fifteen participants got correct. Next question. In a CI/CD pipeline, what is the role of a version control system like Git? Okay, okay. Next question. What is a pipeline in the context of CI/CD? Nine, 10 participants got correct. Moving to the next question. Which of the following is a benefit of implementing CI/CD? Okay, nice stats. What is a feature branch in context of CI/CD? Ten participants. Okay, the next question is what is the main advantage of using containers in a CI/CD pipeline? Okay, nice. Okay, the next question is which of the following best describes the concept of infrastructure as code, IAC, in CI/CD pipeline? Participants get going. And the next question. In CI/CD, what does the term artifact refer to? What is the purpose of automated testing in a CI/CD pipeline? And here we are with the 13th question. Why is rollback important in a CI/CD pipeline? These questions were discussed in the session. Participants got correct. Good number. Okay, this is the second last question.
Okay, guys,
Coming
just
up,
two more
what
questions.
a build server do in a CI/CD pipeline? Okay, the people not coming from their original names, not getting the swags. Who is this Kate Smashers?
Either it's
Great,
Kunal or
great.
it's Siddhant. None of them will get the swags, even if they
For
win.
sure. This is the last question coming up. Which practice is essential for a successful CI/CD pipeline? Okay, with this last decided question, we'll be moving on to our leaderboard. So,
Let's see.
last finger gets it. And we are here with the results. I'm very curious who is this Kate Smashers?
Drop your
Please come
name
up
in the
with your
chat.
real.
Who is this Kate Smashes? Is that you, Nimesh?
Please come up with your real name. And here's the leaderboard. If you can see,
First one is Rima. The first one
Yeah.
is Rima.
Okay.
Second is Vishwaroop. And the third is Pritam Shah. So
Vishwaroop
it's
won't
Deepa
reveal.
Ghosh.
Bye bye.
Let's meet in the next session again.
Yeah. और अपने फ्रेंड्स को भी लेके आना वरना गिव अवे मिस हो सकता है बाय
बिल्कुल
बाय
बिल्कुल. Bye bye.